Hello there, and welcome to The Weary Researcher. I'm so glad you're here tonight. Whether you're settling in for the evening, curling up under warm blankets, or simply letting your mind wander through the cosmos, you've found yourself in just the right place. Tonight, we're going to drift gently through one of the most tantalizing questions in all of physics. What if we could travel faster than light? Now, I should give you a gentle warning before we begin our journey. While this video is designed to help you unwind and ease into rest, there's always the small risk that contemplating the mysteries of faster than light travel might be just fascinating enough to keep you listening. But if you do find yourself wide-eyed at 2 a.m, thinking about warp drives and quantum tunnels, well, at least you'll have learned something extraordinary about the universe. Before we launch ourselves into the cosmic unknown, I'd love to know where in the world you're watching from and what time is it for you right now. Whether you're tuning in at midnight under a canopy of stars or at dawn as the first light touches your window, it's lovely to have you here. If you enjoy these peaceful explorations through science and wonder, please consider giving this video a like and subscribing to the channel. It helps the weary researcher grow, and it means more curious souls like you can drift off with minds full of gentle marvel. So close your eyes if you like, let your shoulders drop, and take a long, slow breath. Tonight, we're going to explore what might happen if we could break the ultimate speed limit of the universe. We'll float through the physics of possibility, drift past the mathematics of the impossible, and wonder together about technologies that might one day carry us to the stars faster than light itself. Let's begin our journey by imagining, just for a moment, that you could step outside your door and travel to the nearest star. Not our sun, but the next closest one, a red dwarf called Proxima Centauri, orbiting in the Alpha Centauri system. It seems close when you look up at the night sky, doesn't it? Just another twinkling point of light among thousands. But that innocent little star sits a staggering 24 trillion miles away from Earth. Even if you could somehow travel at the speed of light itself, the fastest anything can move through our universe, that journey would take you over 4 years. 4 years of travelling through the cold, dark emptiness of space, watching our sun slowly fade to just another star behind you before you'd even glimpse your destination. And Proxima Centauri isn't even particularly far away by cosmic standards. It's practically in our backyard. The centre of our own galaxy lies 26,000 light-years distant. The nearest major galaxy, Andromeda, floats 2.5 million light-years away. At light speed, you could visit Andromeda, spend a pleasant afternoon exploring its spiral arms, and return home just in time to find that 5 million years have passed on Earth. This is the problem that has haunted humanity ever since we first looked up at the stars and wondered what might be waiting for us out there. The universe is unimaginably vast, and we are bound by what seems to be an absolute speed limit. Nothing, according to our best understanding of physics, can travel faster than light. This isn't just a suggestion or a guideline, it's woven into the very fabric of reality itself. The speed of light, roughly 186,000 miles per second, represents more than just how fast photons zip through empty space. It's the universal speed limit, the cosmic constant that governs how quickly information, energy, or matter can move from one place to another. This limit was discovered by Albert Einstein in his theory of special relativity, published in 1905, and it has shaped our understanding of the universe ever since. Einstein showed us that, as anything with mass approaches the speed of light, strange things begin to happen. Time slows down relative to the outside world. The object's mass appears to increase toward infinity. The energy required to accelerate it further grows without bound. It's as if the universe itself conspires to prevent anything from breaking this ultimate barrier. Even light itself, massless and ethereal as it is, cannot exceed its own speed limits. But what if we could find a way around this cosmic constraint? What if there were loopholes in the laws of physics, clever tricks that might allow us to traverse the vast distances between stars not in millennia, but in months, weeks, or even days. The implications would be staggering. Suddenly the galaxy wouldn't be a lonely collection of isolated islands separated by impossible gulfs of space and time. It would become a neighborhood, with worlds and civilizations just a short trip away. Imagine stepping aboard a spacecraft on Monday morning and arriving at a planet orbiting another star by the weekend. You could visit alien worlds the way we now visit other countries, collecting exotic souvenirs and strange memories before returning home for dinner. The night sky would transform from a distant display of unreachable lights into a map of accessible destinations. But the consequences would reach far beyond mere tourism. Faster-than-light travel would revolutionize our understanding of time itself. If you could travel faster than light, you might theoretically be able to arrive at your destination before you left, creating loops in causality that would make yesterday's science fiction seem quaint. You could potentially send messages to your own past, witness events before they happen, or even encounter earlier versions of yourself traveling in the opposite direction through time. The very notion seems to violate everything we think we know about cause and effect. How can an effect precede its cause? How can you arrive somewhere before you've departed? These aren't just philosophical puzzles. They strike at the heart of how reality operates, suggesting that faster-than-light travel might not just be difficult or impractical, but fundamentally impossible in any universe that makes logical sense. And yet, despite these apparent contradictions, physicists haven't entirely given up on the idea. Over the past few decades, theoretical scientists have proposed several ingenious mechanisms that might, under very specific circumstances, allow for something resembling faster-than-light travel. These proposals don't violate Einstein's speed limit directly. Instead, they find creative ways to work around it, like cosmic loopholes in the laws of physics. One of the most elegant ideas is something called an Alcubierre drive, named after the Mexican physicist Miguel Alcubierre, who first proposed it in 1994. Rather than accelerating a spacecraft to incredible speeds, the Alcubierre drive would manipulate spacetime itself. It would contract the fabric of space in front of the ship while expanding it behind, creating a kind of wave that carries the vessel along at speeds that could, in principle, exceed the speed of light. The beautiful thing about this concept is that the spacecraft itself never actually moves faster than light within its local reference frame. It's the space around it that moves, carrying the ship along like a surfer riding a wave. From the perspective of someone inside the vessel, they're sitting perfectly still while the universe flows past them. It's space itself that's doing all the work, folding and stretching to bring distant destinations closer. But the Alcubierre drive comes with its own set of seemingly impossible requirements. To create the necessary distortions in spacetime, you'd need access to exotic matter with negative energy density, something that may not even exist. The energy requirements would be staggering, possibly requiring the mass energy equivalent of entire planets, or even stars. And there are concerns about what would happen to causality if such a drive were actually built and operated. Then there are wormholes, those hypothetical tunnels through spacetime that could connect distant regions of the universe, like cosmic shortcuts. If you could somehow create or discover a stable wormhole, you might be able to step through it and emerge instantly in another part of the galaxy, or even another galaxy entirely. The journey through the wormhole itself wouldn't involve faster-than-light travel. Instead, you'd be taking a much shorter route through the curved geometry of spacetime. Wormholes have a long and distinguished history in theoretical physics, dating back to solutions of Einstein's field equations discovered in the early 20th century, but like the Alcubierre drive, they come with their own set of problems. Most theoretical wormholes would collapse before anything could pass through them. To keep one open and stable, you'd likely need that same exotic matter with negative energy properties, assuming such material could exist at all. Recent research has suggested some intriguing possibilities, though. Some physicists have proposed that modifications to our understanding of gravity might make stable wormholes possible without requiring exotic matter. Others have conducted experiments with quantum systems that seem to exhibit wormhole-like behaviour, though these operate on scales far too small to transport anything larger than information. There's also the possibility of tachyons, hypothetical particles that would always travel faster than light. Unlike ordinary matter, which would require infinite energy to reach light speed, tachyons would require infinite energy to slow down to light speed. They would exist in a realm where faster means lower energy, creating a mirror image of our familiar physics. The mathematics of tachyons has been worked out in detail, and recent research has suggested that some of the apparent contradictions they create might be resolvable through more sophisticated treatments of quantum field theory. But no tachyons have ever been detected, and many physicists suspect they may be mathematical curiosities rather than physical realities. Perhaps the most mysterious aspect of faster-than-light phenomena is quantum entanglement, sometimes called spooky action at a distance by Einstein himself. When two particles become entangled, measuring one instantly affects the other, regardless of how far apart they are. This correlation appears to happen faster than light could travel between the particles, seemingly violating the cosmic speed limit. But quantum entanglement doesn't actually allow for faster-than-light communication or travel. While the correlations between entangled particles do appear instantaneous, you can't use this connection to send useful information faster than light. The quantum realm operates by its own strange rules, where influence and information follow different pathways than in our everyday world. As we float through these possibilities, from warp drives to wormholes, from tachyons to quantum tunnels, we find ourselves at the intersection of rigorous science and boundless imagination. Each proposed mechanism for faster-than-light travel pushes against the boundaries of known physics, exploring the outer limits of what might be possible in a universe governed by quantum mechanics and general relativity. The question isn't just whether we could travel faster than light, but what such travel would mean for our understanding of reality itself. Would it open doorways to parallel universes? Would it allow us to explore the deep structure of time? Would it reveal new layers of physics that we can barely imagine today? Some of these ideas may forever remain in the realm of mathematical speculation, beautiful solutions to equations that describe universes unlike our own. Others might eventually find expression in technologies so advanced they would seem like magic to us today, and a few might already be operating around us in ways we don't yet recognize, hidden in the quantum foam that underlies all of space and time. What's particularly fascinating is how recent developments in theoretical physics have begun to chip away at some of these seemingly insurmountable barriers. In the past few years, researchers have made remarkable progress in understanding how spacetime might be manipulated in ways that seemed impossible just decades ago. Take the work of Dr. Eric Lentz at the University of Göttingen, who in 2021 published a revolutionary paper that reimagined the entire concept of warp drive physics. Unlike the original Alcubierre model, which required exotic matter with negative energy properties, Lentz proposed a completely different approach. His calculations suggest that it might be possible to create warp-like effects using only conventional matter and energy, though still in quantities that would challenge our current technological capabilities. Lentz's insight was elegantly simple, yet profound. Instead of trying to contract space in front of a spacecraft and expand it behind, his model creates wave-like distortions in spacetime that propagate faster than light, while carrying a bubble of normal space along with them. The spacecraft would ride within this bubble, never actually exceeding light speed locally, but still arriving at distant destinations faster than light, travelling through undisturbed space could manage. The energy requirements, while still enormous, are no longer infinite. Lentz calculated that his drive would need energy equivalent to the mass of a large planet, perhaps similar to Jupiter. That's still far beyond anything we could realistically achieve today. But it's not fundamentally impossible. It's the difference between needing infinite resources and needing really, really substantial ones. Meanwhile, at NASA's EagleWorks laboratory, researchers have been conducting actual experiments to test whether microscopic warp effects might be detectable with current technology. Led by physicist Harold "Sonny" White, the team has been using sophisticated interferometers to look for tiny distortions in spacetime that might indicate the presence of warp-like phenomena. Their experiments involve creating electromagnetic fields in carefully controlled configurations, then measuring whether these fields produce any detectable curvature in the surrounding space. While they haven't yet achieved anything resembling a functional warp drive, they've made important progress in understanding how such effects might manifest and how they could be measured. White's approach builds on modifications to the original Alcubierre concept, particularly the idea that shaping the warp bubble into a torus or ring-like structure could dramatically reduce the energy requirements. Instead of needing exotic matter with negative energy density, White's calculations suggest that clever engineering of the field geometry might make warp effects achievable with more conventional, though still exotic, forms of energy. But perhaps the most intriguing developments have come from an unexpected direction entirely. Quantum physicists working with advanced computer simulations have begun creating what they call quantum wormholes inside quantum processors. These aren't the massive space-time tunnels of science fiction, but rather microscopic quantum analogues that exhibit some of the same mathematical properties as theoretical wormholes. In late 2022, researchers at Google, Caltech, and Harvard announced that they had successfully created a quantum system that behaves like a traversable wormhole. Using a quantum computer called Sycamore, they were able to demonstrate that information could be transmitted through this quantum wormhole in a way that's mathematically equivalent to travelling through a gravitational wormhole in curved spacetime. The experiment involved creating two separate quantum systems that were entangled with each other, then introducing carefully controlled disturbances that allowed information to travel from one system to the other through what the researchers described as a quantum tunnel. While this tunnel exists only in the abstract mathematical space described by quantum mechanics, not in physical spacetime, it demonstrates that wormhole-like effects are not purely theoretical. These quantum wormholes operate through a process called quantum teleportation, where information about a quantum state can be transmitted instantly across any distance using entangled particles. The information doesn't actually travel through space in the conventional sense. Instead, it appears simultaneously at both ends of the entangled system, as if it had tunneled through a hidden dimension connecting the two locations. The implications are tantalizing. If quantum wormholes can exist in the microscopic realm of quantum mechanics, might it be possible to scale them up to macroscopic sizes? Could we eventually learn to create physical wormholes that connect different regions of spacetime, allowing for instantaneous travel across cosmic distances? The challenge lies in bridging the gap between quantum mechanics, which governs the behavior of individual particles, and general relativity, which describes the large-scale structure of space and time. These two theories have coexisted peacefully for nearly a century, each supremely successful in its own domain, but they operate according to fundamentally different principles that have proven remarkably difficult to unify. Recent work in string theory and loop quantum gravity has suggested some promising approaches to this unification problem. String theorists propose that at the smallest scales, space and time themselves might be made up of tiny vibrating strings or loops, creating a quantum foam that could potentially support wormhole-like structures. Loop quantum gravity suggests that spacetime has a discrete, granular structure at the Planck scale, which might allow for exotic topologies that don't exist in smooth, continuous spacetime. But even if we could create stable wormholes or functional warp drives, the consequences for causality would be profound and potentially paradoxical. Faster-than-light travel doesn't just mean getting to distant places quickly. It also means that the sequence of events becomes relative, dependent on your frame of reference and the path you take through spacetime. Imagine, for instance, that you use a warp drive to travel to a star system 20 light-years away, arriving there in just 1 week. From your perspective, you've made a quick trip to a distant destination. But now, imagine that someone else, traveling at nearly the speed of light in the opposite direction, observes your journey. Due to the relativistic effects described by Einstein's special theory of relativity, they might see you arriving at your destination before you departed from Earth. This isn't just a curious side effect, it's a fundamental challenge to our understanding of cause and effect. If you could arrive somewhere before you left, you could theoretically send a message back to Earth that would arrive before your departure, warning yourself not to make the trip. But if you don't make the trip, how did the warning message get sent? These temporal paradoxes have led some physicists to propose what's called the chronology protection conjecture, suggested by Stephen Hawking. This conjecture holds that the laws of physics will always conspire to prevent the formation of closed time-like curves, the mathematical structures that would allow for time travel into the past. Whenever you try to create a situation that would violate causality, quantum effects or other physical processes would intervene to prevent it. But the chronology protection conjecture remains unproven, and some recent research has suggested that it might not be as ironclad as once believed. Certain solutions to Einstein's field equations do seem to allow for closed, time-like curves under very specific circumstances, though these typically require exotic forms of matter or energy that may not exist in our universe. The question of faster-than-light travel thus becomes intimately connected with our understanding of time itself. If the universe is deterministic, with a single fixed timeline stretching from the Big Bang to the heat death of the cosmos, then faster-than-light travel might indeed be impossible. But if time is more flexible, with multiple possible timelines or parallel histories, then superluminal travel might be not just possible, but inevitable. Recent developments in quantum mechanics have suggested that the nature of time might be far stranger than we previously imagined. The many worlds interpretation of quantum mechanics proposes that every quantum measurement creates multiple parallel universes, each containing a different outcome. In such a multiverse, faster-than-light travel might not create paradoxes, but rather allow for movement between different branches of reality. Other interpretations of quantum mechanics suggest that time itself might be emergent, arising from more fundamental quantum processes rather than being a basic feature of reality. If time is indeed emergent, then the apparent impossibility of faster-than-light travel might be more of a limitation of our current understanding than a fundamental law of nature. As we drift deeper into these possibilities, we find ourselves contemplating not just the mechanics of faster-than-light travel, but the very nature of existence itself. Would superluminal spacecraft carry us to distant worlds, or would they transport us to alternate realities where the laws of physics operate differently? Would we encounter alien civilizations that have mastered these technologies, or would we discover that consciousness itself is the key to transcending the speed of light? Some researchers have suggested that biological systems might already exploit quantum effects that could, in principle, be scaled up to achieve faster-than-light phenomena. Photosynthesis, for instance, appears to use quantum coherence to transfer energy with near-perfect efficiency. The human brain might use quantum processes in ways we don't yet understand. Perhaps the key to faster-than-light travel lies not in building exotic spacecraft, but in understanding and enhancing the quantum processes that already operate within living systems. The possibilities stretch out before us like an infinite cosmic highway, each more intriguing than the last. As we float through these speculations, we're reminded that the boundary between science and wonder has always been more porous than it appears. Today's impossibility often becomes tomorrow's breakthrough, and the questions that seem most unanswerable frequently point toward the most profound discoveries. The search for faster-than-light travel has led scientists down some truly unexpected pathways, each more intriguing than the last. One of the most surprising developments has come from studying the quantum vacuum itself, that supposedly empty space between particles that turns out to be anything but empty. At the smallest scales, the vacuum seethes with virtual particles constantly popping into existence and annihilating each other in a cosmic dance that happens far too quickly for us to observe directly. This quantum foam, as physicists call it, might hold the key to manipulating spacetime in ways we're only beginning to understand. Some researchers have proposed that by carefully orchestrating the behavior of virtual particles, we might be able to create regions where the effective speed of light is different from its usual value. Imagine driving on a highway where the speed limit changes from mile to mile. If you could create such zones in space, a spacecraft might be able to travel through regions where light moves faster, effectively allowing for superluminal travel without breaking any fundamental laws. The mathematics behind this idea are still being worked out, but early calculations suggest it might be possible to create what researchers call fast light regions using intense electromagnetic fields or exotic quantum states. The energy requirements would still be enormous, but they wouldn't necessarily require the impossible negative energy densities that have plagued other faster-than-light proposals. Another fascinating possibility emerges from the study of black holes and their bizarre properties. Near the event horizon of a rotating black hole, spacetime itself gets dragged along in a phenomenon called frame dragging. In these regions, the very definition of standing still becomes twisted, and it might theoretically be possible for objects to move faster than light relative to distant observers, while still moving slower than light in their local reference frame. Some theoretical physicists have proposed using artificial black holes or black hole analogues to create similar frame-dragging effects on demand. By carefully controlling the rotation and mass of such objects, it might be possible to create corridors through space where faster-than-light travel becomes not just possible, but natural. The technical challenges would be staggering, requiring the ability to create and manipulate black holes with the same precision we now use to control laser beams. But the underlying physics appears sound. The study of dark energy, that mysterious force that's causing the expansion of the universe to accelerate, has also opened new avenues for faster-than-light research. Dark energy appears to be stretching space itself, creating new space between galaxies at a rate that effectively moves distant galaxies away from us faster than light could travel. If we could somehow harness or mimic dark energy on a local scale, we might be able to create our own regions of expanding space that could propel spacecraft to superluminal velocities. Recent observations of the cosmic microwave background radiation have revealed subtle patterns that might provide clues about how dark energy operates. Some researchers have proposed that these patterns represent the signatures of quantum fluctuations that were stretched to cosmic scales during the rapid expansion of the early universe. If we could recreate similar quantum fluctuations in a controlled laboratory setting, we might be able to generate our own pocket universes of expanding space. But perhaps the most intriguing developments have come from an entirely different direction: the study of consciousness and its relationship to quantum mechanics. A growing number of physicists have begun to suspect that consciousness might play a more fundamental role in the structure of reality than previously thought. Some interpretations of quantum mechanics suggest that conscious observation is necessary to collapse quantum wave functions and determine the outcome of quantum events. If consciousness does indeed have a special role in quantum mechanics, then perhaps conscious beings could learn to influence quantum processes in ways that transcend the usual limitations of space and time. This isn't just New Age speculation, it's based on serious mathematical work by physicists like Roger Penrose and Stuart Hameroff, who have proposed that consciousness emerges from quantum processes in the microtubules of brain cells. Their theory suggests that the brain might operate as a quantum computer, processing information using quantum superposition and entanglement in ways that classical computers cannot. If this is true, then perhaps sufficiently advanced conscious beings could learn to manipulate quantum fields directly, potentially achieving faster-than-light communication or even transportation through pure thought. The implications extend far beyond just getting from point A to point B quickly. If consciousness can influence quantum processes, then perhaps what we think of as physical travel through space might eventually be replaced by something more akin to quantum teleportation of consciousness itself. Instead of moving your body through space, you might learn to transfer your consciousness instantaneously to distant locations, perhaps even to multiple locations simultaneously. This brings us to one of the most profound questions raised by faster-than-light travel. What exactly would be travelling? In our everyday experience, we think of ourselves as solid, continuous entities moving through space from moment to moment. But quantum mechanics suggests a very different picture. At the deepest level, you're not a thing but a pattern, a complex arrangement of quantum fields that maintains its structure through constant interaction and exchange with the surrounding environment. If this quantum view of identity is correct, then faster-than-light travel might not involve moving your physical body at all. Instead, it might involve transmitting the pattern that defines you, recreating that pattern at a distant location, and allowing the original to dissolve. From your subjective perspective, you would simply find yourself somewhere else instantaneously. But would the consciousness that arrives at the destination really be you, or would it be a copy that merely thinks it's you? These questions become even more complex when we consider that quantum mechanics suggests reality itself might be fundamentally information-based. Some physicists have proposed that what we think of as matter and energy are really just different ways of organizing quantum information. If this is true, then the distinction between traveling through space and transmitting information across space might be meaningless. You might already be traveling at the speed of light, in the sense that the quantum information that defines you is constantly being updated and propagated through the quantum fields that permeate all of space. Recent work in quantum biology has revealed that living systems routinely exploit quantum effects that were once thought to be too delicate to survive in warm, noisy, biological environments. Plants use quantum coherence to achieve near-perfect efficiency in photosynthesis. Birds might use quantum entanglement to navigate using Earth's magnetic field. Some researchers have even suggested that DNA might use quantum tunneling effects to facilitate mutations and evolution. If biological systems can harness quantum effects for practical purposes, then perhaps the path to faster-than-light travel lies not in building exotic spacecraft, but in enhancing and amplifying the quantum processes that already operate within living organisms. Perhaps sufficiently advanced biological beings could evolve natural faster-than-light capabilities, just as some organisms have evolved the ability to see ultraviolet light or navigate using magnetic fields. This biological approach to faster-than-light travel suggests that the universe might already be full of superluminal travelers we simply don't recognize as such. Perhaps consciousness itself is a faster-than-light phenomenon, connecting minds across vast distances in ways we're only beginning to understand. Perhaps what we call intuition or telepathy represents primitive forms of faster-than-light communication that could eventually be developed into full-fledged transportation systems. The more we explore these possibilities, the more we realize that faster-than-light travel might not be about overcoming the limitations of physics, but about discovering aspects of physics we don't yet understand. The universe has surprised us before with phenomena that seemed impossible until we developed the conceptual frameworks to understand them. Quantum mechanics itself was once dismissed as absurd by many physicists, including Einstein, yet it has proven to be one of the most successful theories in the history of science. Perhaps faster-than-light travel is waiting for a similar conceptual breakthrough, a new way of thinking about space, time, and causality that will make the impossible seem obvious in retrospect. The seeds of such a breakthrough might already be germinating in the work being done today in laboratories around the world, in the quiet offices of theoretical physicists wrestling with exotic equations, and in the imaginations of dreamers who refuse to accept that the stars must forever remain beyond our reach. As we float through these speculations, we're reminded that the boundary between what is and what might be has always been more fluid than it appears. Every great discovery in physics has involved a fundamental shift in perspective, a new way of seeing reality that reveals possibilities that were hidden in plain sight. The search for faster-than-light travel is really a search for new ways of understanding the deeper structures of existence itself. And perhaps that's the most beautiful aspect of this quest. Whether or not we ever build functional warp drives or step through traversable wormholes, the very act of seriously contemplating faster-than-light travel pushes us to question our most basic assumptions about reality. It forces us to confront the possibility that the universe is far stranger and more wonderful than we ever imagined, filled with hidden connections and secret pathways that could transform our understanding of what it means to exist in space and time. In pursuing the dream of travelling faster than light, we're not just seeking a more efficient form of transportation. We're embarking on a journey of discovery that could reshape our understanding of consciousness, causality, and the fundamental nature of reality itself. And in that sense, perhaps we're already travelling faster than light, carried along by the boundless curiosity and imagination that has always been humanity's greatest engine for transcending the apparent limitations of the possible. The research continues in quantum laboratories and theoretical calculations, in computer simulations and thought experiments. Each small step forward brings us closer to understanding whether faster-than-light travel is a distant dream or an inevitable destination. And as we drift through these possibilities tonight, we can take comfort in knowing that somewhere in the quiet corners of universities and research centres around the world, brilliant minds are working to unlock the secrets that might one day carry us to the stars faster than light itself can travel. The journey has only just begun, and the most extraordinary discoveries may still be waiting for us in the vast, mysterious landscape of the possible. As you close your eyes tonight, remember that the universe is far more malleable than it appears, full of hidden pathways and secret shortcuts that could one day transform a galaxy of distant lights into a neighbourhood of accessible worlds. The speed of light may be the ultimate limit today, but tomorrow's physics might reveal that the only real limitation is the scope of our imagination. But even as we contemplate these exotic possibilities, we must also consider what faster-than-light travel would mean for the very structure of society and human civilization. Imagine a world where the journey to Alpha Centauri takes no longer than a weekend trip to another continent. The implications would ripple through every aspect of human culture, economics, and philosophy in ways that are difficult to fully grasp. Consider the simple question of time zones. On Earth, we've organised our lives around the fact that it takes roughly 24 hours for our planet to rotate, creating a predictable cycle of day and night that moves across the surface at a steady pace. But what happens when you can travel to another star system faster than Earth rotates? You might leave home on Tuesday morning and arrive at your destination the previous Monday, not because you've travelled backward in time, but because the local calendar on your destination world operates according to completely different cycles. The economic implications would be staggering. Our entire global economy is built around the assumption that moving goods and people across vast distances takes time and energy. Shipping containers cross oceans in weeks, airline flights cross continents in hours. But if you could transport cargo instantaneously across interstellar distances, the very concept of local versus global markets would become meaningless. Why manufacture anything on Earth when you could access the resources of entire star systems as easily as walking to the corner store? Perhaps even more profound would be the psychological and philosophical implications. Human beings have always lived with the knowledge that there are places we cannot go, experiences we cannot have, people we cannot meet because they exist too far away in space or time. This limitation has shaped our art, our literature, our dreams, and our sense of what it means to be human. Remove that limitation, and you remove one of the fundamental constraints that has defined human existence since our species first looked up at the stars. Would we still be human in any recognizable sense if we could travel faster than light, or would we evolve into something entirely different, beings for whom distance and separation are quaint historical concepts rather than lived realities? The question becomes even more complex when we consider that faster-than-light travel might not just connect different places, but different times and possibly even different versions of reality itself. Recent theoretical work has suggested that the universe might be far more interconnected than we previously imagined. String theory proposes that what we experience as separate particles and forces might actually be different vibrations of the same underlying strings existing in dimensions we cannot directly perceive. Loop quantum gravity suggests that space and time themselves might have a granular structure at the smallest scales, like pixels in a cosmic computer screen. If these theories are correct, then faster-than-light travel might not involve moving through space in the conventional sense at all. Instead, it might involve learning to navigate through these hidden dimensions, stepping outside our familiar three-dimensional space to take shortcuts through the higher dimensional structures that underlie reality. Imagine being able to fold a piece of paper so that two distant points touch. From the perspective of someone living on the surface of the paper, these points would seem impossibly far apart. But from the perspective of someone who can step into the third dimension, they would be directly adjacent. The mathematics of higher dimensional space suggests that our universe might work in a similar way. What appear to us as vast cosmic distances might actually be illusions created by our limited perspective. Two galaxies that seem billions of light years apart in our three-dimensional view might actually be neighbours when viewed from the perspective of higher dimensions. Learning to travel faster than light might really mean learning to step outside our dimensional limitations and navigate through the true structure of reality. This possibility has led some researchers to investigate whether consciousness itself might naturally operate in higher dimensions. After all, when you close your eyes and imagine a distant place, your mental image appears instantaneously without having to travel through the intervening space. When you dream, you can visit locations that exist only in your mind, moving from one to another without any sense of journeying through space. Perhaps these mental abilities represent primitive forms of higher dimensional navigation that could eventually be developed into physical transportation capabilities. The relationship between mind and space becomes even more intriguing when we consider the role of information in modern physics. At the quantum level, the distinction between matter, energy, and information becomes increasingly blurred. Some physicists have proposed that information is the most fundamental aspect of reality, with matter and energy being different ways of organizing and processing information. If this is true, then the question of faster-than-light travel becomes a question about the speed at which information can be transmitted and processed. Quantum entanglement already demonstrates that certain types of information can appear to travel instantaneously across any distance. When two particles become entangled, measuring one immediately affects the state of the other, regardless of the spatial separation between them. While this correlation cannot be used to send conventional messages faster than light, it does suggest that the universe contains hidden channels for information transfer that operate outside our normal understanding of space and time. Perhaps the key to faster-than-light travel lies in learning to encode ourselves as information and transmit that information through these quantum channels. Your body, after all, is really just a very complex arrangement of atoms, and each atom is just a pattern of quantum fields. In principle, all the information needed to reconstruct you could be stored and transmitted like any other data. The technical challenges would be immense, requiring the ability to map and manipulate quantum states with perfect precision, but the underlying physics appears to be sound. This informational approach to faster-than-light travel raises profound questions about the nature of identity and consciousness. If you could transmit the complete information pattern that defines you to a distant location and reconstruct yourself there, would the reconstructed version really be you, or would it be a copy that merely believes it has your memories and experiences? And what would happen to your consciousness during the transmission process? Would there be a moment of discontinuity, a brief death followed by resurrection, or would your awareness somehow persist throughout the journey? These questions become even more complex when we consider that quantum mechanics suggests consciousness might not be localized in space, the way we typically assume. The quantum states that define your brain exist in a superposition of possibilities until they're measured or observed. In some interpretations of quantum mechanics, consciousness itself might be the process that collapses these quantum superpositions, determining which possibility becomes real. If consciousness operates at the quantum level in this way, then perhaps it already transcends the normal limitations of space and time. Some researchers have proposed that consciousness might be a field phenomenon, similar to electromagnetic fields, but operating through mechanisms we don't yet understand. Just as electromagnetic fields can extend across vast distances and carry information at the speed of light, consciousness fields might extend across cosmic distances and carry information faster than light. This would explain certain puzzling phenomena reported throughout history, from telepathic experiences to the feeling of connection that some people report with distant loved ones. If consciousness is indeed a field phenomenon, then faster-than-light travel might not require exotic spacecraft or manipulated spacetime. Instead, it might require learning to project consciousness across cosmic distances, allowing you to experience distant locations directly without moving your physical body. This form of travel would be instantaneous, unlimited by distance, and would require no energy beyond the mental effort needed to maintain the conscious projection. The biological basis for such abilities might already exist in rudimentary form. Recent research has revealed that the human brain contains millions of magnetite crystals, the same mineral that allows some animals to navigate using Earth's magnetic field. Some researchers have suggested that these crystals might serve as quantum sensors, allowing the brain to detect and process quantum information in ways we don't yet understand. Perhaps learning to consciously control these quantum sensing abilities could lead to forms of perception and travel that transcend physical limitations. The implications extend beyond individual consciousness to collective consciousness as well. If minds can connect across vast distances through quantum fields, then perhaps entire civilizations could merge into collective intelligences that span multiple star systems. Instead of individual beings traveling from world to world, we might evolve into distributed consciousnesses that exist simultaneously across cosmic distances, sharing thoughts and experiences instantaneously regardless of physical separation. This collective approach to faster-than-light travel would solve many of the paradoxes that plague other proposals. If consciousness naturally operates faster than light, then the apparent violations of causality that worry physicists might simply reflect our limited understanding of how consciousness interacts with space and time. Perhaps the universe is already filled with faster-than-light travelers in the form of conscious beings who have learned to transcend their physical limitations, and we simply don't recognize them because we're still trapped in purely material thinking. The search for faster-than-light travel might thus be really a search for a new understanding of consciousness and its relationship to the physical universe. Every meditation practice, every moment of deep concentration, every experience of intuition or inspiration might represent a step toward developing the conscious abilities that could eventually allow for instantaneous travel across cosmic distances. As we drift deeper into these possibilities, we begin to see that faster-than-light travel might not be about conquering space and time, but about transcending our current understanding of what we are and what we might become. The journey to the stars might really be a journey inward, toward a fuller understanding of consciousness and its unlimited potential. And perhaps that's the most beautiful aspect of this quest. In seeking to travel faster than light, we're not just trying to reach distant worlds, we're trying to discover the deepest truths about ourselves and our place in the cosmic order. The universe, it seems, might be far more alive and conscious than we ever imagined, filled with intelligences that have already learned to transcend the apparent limitations of space and time. Our own evolution toward faster-than-light capabilities might simply be part of a natural progression toward joining this cosmic community of consciousness, where distance becomes irrelevant and the entire universe becomes accessible through the expansion of awareness itself. Tonight, as you rest and let your mind wander through these infinite possibilities, remember that you might already possess the seeds of faster-than-light travel within your own consciousness. Every dream that carries you to distant places, every moment of connection with someone far away, every intuitive leap that transcends logical reasoning might be a glimpse of abilities that could eventually allow humanity to explore the cosmos, not through technology, but through the unlimited potential of consciousness itself. The stars are calling, not just to our rockets and spacecraft, but to our minds and spirits. And perhaps the day will come when we answer that call not by building faster ships, but by discovering that we were always capable of travelling at the speed of thought, limited only by our belief in limitations themselves. The universe awaits, vast and mysterious, and full of wonders beyond imagination, accessible not through the conquest of physics, but through the expansion of consciousness into its true, unlimited nature. But perhaps the most tantalizing aspect of faster-than-light travel isn't the technology itself, but what it might reveal about the hidden architecture of reality. Recent discoveries in quantum field theory have begun to suggest that what we perceive as empty space might actually be a seething ocean of virtual particles and quantum fluctuations, constantly creating and destroying themselves in patterns too brief and subtle for us to observe directly. This quantum foam, as physicists call it, might hold the key to understanding how faster-than-light phenomena could operate without violating the fundamental laws of physics. Imagine space-time not as a smooth fabric, but as a turbulent sea, where the surface appears calm from a distance, but reveals incredible complexity when viewed up close. In this quantum ocean, particles don't actually travel from point A to point B in the way we might imagine. Instead, they flicker in and out of existence, borrowing energy from the vacuum itself before paying it back in accordance with the uncertainty principle. Some researchers have proposed that advanced civilizations might learn to surf these quantum fluctuations, using the natural turbulence of spacetime to achieve apparent faster-than-light travel without actually exceeding the speed of light in any local reference frame. It's a bit like learning to ride the currents in a river to travel faster than the water itself is flowing. The spacecraft wouldn't be moving through space so much as being carried along by carefully orchestrated patterns in the quantum substrate that underlies all of reality. This approach has led to some fascinating experimental work in laboratories around the world. Scientists have discovered that, under certain conditions, they can create what they call squeezed vacuum states, regions of space where the quantum fluctuations are temporarily suppressed in one direction and enhanced in another. While these effects are currently microscopic and fleeting, they demonstrate that the quantum vacuum can indeed be manipulated in ways that would have seemed impossible just a few decades ago. The mathematics behind these squeezed vacuum states suggest that it might eventually be possible to create stable corridors through space where the effective properties of the vacuum are altered. In these corridors, light itself might travel faster or slower than its usual speed, creating regions where the cosmic speed limit is temporarily relaxed. A spacecraft entering such a corridor could theoretically travel at its normal velocity relative to the local vacuum while still appearing to exceed the speed of light when viewed from outside the corridor. But the implications go far deeper than mere transportation. If the quantum vacuum can be manipulated and controlled, then perhaps the distinction between matter and empty space is far more fluid than we've assumed. Your body, after all, is mostly empty space, with vast gaps between the nuclei and electrons that make up your atoms. From a quantum perspective, you're really more of a stable pattern in the quantum field than a solid object moving through empty space. This field-based view of matter suggests that faster-than-light travel might not involve moving objects through space at all, but rather propagating patterns through the quantum field at speeds that transcend our usual understanding of motion. Think of how a wave can travel across the surface of a pond faster than any individual water molecule moves. The wave is real and carries energy and information, but it's not a thing in the conventional sense. It's a pattern that moves through the medium. Perhaps consciousness itself operates in a similar way, as a pattern that can propagate through the quantum field of spacetime at speeds that aren't limited by the movement of matter. This would explain some of the puzzling aspects of consciousness that have baffled scientists for centuries. How can a thought appear instantly in your mind? How can you imagine yourself in a distant location without any sense of travelling through the intervening space? How can some people report experiences of connection or communication that seem to transcend physical distance? Recent research in quantum biology has revealed that living systems routinely exploit quantum effects that were once thought to be too fragile to survive in warm, noisy, biological environments. Photosynthesis uses quantum coherence to achieve near-perfect energy transfer efficiency. Some birds appear to use quantum entanglement in their navigation systems. Even human consciousness might depend on quantum processes occurring in the microtubules of brain cells, creating a biological quantum computer that operates according to principles we're only beginning to understand. If biological systems can harness quantum effects for practical purposes, then perhaps the path to faster-than-light travel lies not in building exotic machines, but in understanding and enhancing the quantum processes that already operate within living organisms. Maybe we don't need to invent faster-than-light technology because we already are faster-than-light technology, operating through quantum mechanisms that we haven't yet learned to consciously control. This biological approach to faster-than-light phenomena suggests that the universe might already be filled with superluminal travelers that we simply don't recognize as such. Every time a bird navigates using quantum entanglement, every time a plant achieves quantum coherence in photosynthesis, every time your brain processes information using quantum computation, faster than light effects might be occurring right under our noses. The challenge isn't necessarily to create new physics, but to understand the physics that's already operating within and around us. Perhaps consciousness itself is a faster-than-light phenomenon, connecting minds across vast distances through quantum channels that operate outside our normal understanding of space and time. The feeling of instant connection with a loved one, the sudden flash of insight that seems to come from nowhere, the dreams that carry us to places we've never been might all be examples of consciousness naturally transcending the speed of light barrier. This possibility has profound implications for how we think about identity and individuality. If consciousness can operate faster than light, then perhaps the boundaries between individual minds are more permeable than we assume. Maybe what we think of as separate consciousnesses are really localized expressions of a larger interconnected awareness that spans cosmic distances instantaneously. Some interpretations of quantum mechanics already suggest something similar. The many worlds interpretation proposes that every quantum measurement creates multiple parallel universes, each containing different outcomes. But what if these parallel universes aren't actually separate? What if they're all connected through quantum channels that allow for instantaneous communication and travel between different branches of reality? In such a multiverse, faster-than-light travel might not just connect different locations in space, but different possibilities in the quantum realm. You might not just travel to Alpha Centauri, but to the version of Alpha Centauri where life evolved differently, where physics operates according to slightly different rules, where consciousness has developed capabilities that seem magical from our current perspective. The mathematical framework for such travel already exists in the equations of quantum mechanics. The Schrödinger equation describes how quantum systems evolve over time, but it doesn't specify which timeline is the real one. All possible timelines exist simultaneously in what physicists call superposition, until something causes the quantum wave function to collapse into a specific outcome. But what if consciousness could learn to navigate between these different timelines without causing collapse? What if sufficiently advanced beings could move through the quantum multiverse, like surfers riding waves, experiencing multiple realities simultaneously and choosing which one to make manifest through the act of observation? This quantum approach to faster-than-light travel would solve many of the paradoxes that plague other proposals. If you can travel between parallel timelines, then arriving at your destination before you departed wouldn't create a paradox. It would simply mean you arrived in a timeline where you had left earlier, while the timeline where you originally existed continues unchanged. Causality would be preserved because each timeline maintains its own consistent sequence of events. Recent experiments in quantum mechanics have begun to explore these possibilities in microscopic systems. Researchers have demonstrated that quantum particles can indeed exist in superposition states that span multiple possible histories simultaneously. They've shown that quantum information can be processed in ways that transcend classical logic, solving problems that would be impossible for conventional computers. While these experiments operate on scales far too small to transport human beings, they establish the proof of principle for quantum navigation through multiple realities. Perhaps the key to faster-than-light travel lies in scaling up these quantum effects, learning to maintain quantum coherence in larger and larger systems until entire spacecraft, or even entire human beings, can exist in superposition states that span multiple locations simultaneously. The technological challenges would be immense, requiring the ability to isolate complex systems from environmental decoherence while maintaining precise control over quantum states. But the underlying physics appears sound, and recent advances in quantum computing and quantum error correction suggest that such control might eventually be achievable. But even more intriguingly, some researchers have proposed that consciousness might naturally operate at quantum scales in ways that could bypass these technological requirements entirely. If the mind can directly influence quantum processes, then perhaps sufficiently trained individuals could learn to navigate the quantum multiverse using nothing more than focused intention and quantum awareness. This wouldn't be magic in the supernatural sense, but rather a natural extension of abilities that might already exist in rudimentary form. Every act of quantum measurement involves consciousness interacting with quantum systems to determine outcomes. Perhaps learning to consciously control these interactions could allow for direct manipulation of quantum fields and navigation through higher dimensional space. The implications extend beyond individual travel to collective consciousness and species-wide evolution. If humans could learn to operate as quantum beings, we might eventually evolve into a distributed intelligence that exists simultaneously across multiple realities and locations. Instead of individual humans traveling from world to world, we might become a cosmic consciousness that experiences the entire universe directly, without the need for physical transportation at all. This evolutionary perspective suggests that faster-than-light travel might not be a technology we develop, but a capability we grow into as our understanding of consciousness and quantum mechanics deepens. Perhaps the universe is already filled with advanced consciousnesses that have transcended physical limitations, and our own journey toward faster-than-light capabilities is simply part of a natural progression toward joining this cosmic community. The search for faster-than-light travel thus becomes a search for the deepest truths about consciousness, reality, and our place in the cosmic order. Every meditation that quiets the mind, every moment of deep concentration that transcends ordinary thinking, every experience of connection that bridges apparent separation, might be a step toward developing the awareness necessary for quantum navigation through space and time. As we float through these possibilities, we begin to see that the question isn't really whether faster-than-light travel is possible, but whether we're ready to expand our understanding of what's possible. The universe might already be offering us countless pathways to transcend physical limitations, but we can only perceive and utilize those pathways when our consciousness evolves to match their subtlety and sophistication. Perhaps the greatest barrier to faster-than-light travel isn't physics or technology, but our own assumptions about what we are and what we're capable of becoming. The journey to the stars might really be a journey inward, toward a fuller understanding of consciousness and its unlimited potential for transcending apparent limitations. Tonight, as you rest and let these ideas settle into your awareness, consider the possibility that you might already possess everything needed for faster-than-light travel, not in the form of exotic technology or manipulated space-time, but in the form of consciousness itself, with its natural ability to transcend the boundaries of space and time through the simple act of aware attention. The stars are calling, not just to our rockets and machines, but to our minds and hearts. And perhaps the day will come when we answer that call, not by conquering the universe through force, but by discovering that we were always part of a cosmic intelligence that naturally operates faster than light, limited only by our belief in limitations themselves. The universe awaits, vast and mysterious, and closer than we ever imagined, accessible not through the manipulation of matter and energy, but through the expansion of consciousness into its true, unlimited nature. And in that expansion, we might discover that faster-than-light travel was never about getting somewhere else, but about recognizing that we were already everywhere, always, connected to all things through the invisible threads of awareness that bind the cosmos together in one magnificent, instantaneous whole. As these thoughts drift through your mind, like gentle waves lapping at the shore of consciousness. Remember that the greatest discoveries often come not through struggling against the apparent limitations of reality, but through relaxing into a deeper understanding of what reality actually is. The speed of light might seem like an absolute barrier from one perspective, but from another perspective entirely, it might simply be one note in a cosmic symphony of possibilities that we're only beginning to hear. The journey toward understanding faster than light travel has led researchers down some truly unexpected pathways, each more intriguing than the last. One of the most surprising developments has emerged from studying something called the Casimir effect, a strange quantum phenomenon discovered in the 1940s by Dutch physicist Hendrik Casimir. When two metal plates are placed extremely close together in a vacuum, they experience a tiny attractive force that seems to come from nowhere. This force arises from the quantum vacuum itself, that supposedly empty space between the plates that turns out to be seething with virtual particles. The metal plates actually alter the quantum fluctuations in the space between them, creating a region where there are fewer virtual particles than in the surrounding vacuum. The pressure from the quantum foam outside the plates literally pushes them together, demonstrating that empty space has measurable physical properties that can be manipulated. Recent theoretical work has suggested that variations of the Casimir effect might be used to create what physicists call negative energy densities, regions of space where the normal relationship between matter and energy is inverted. These negative energy regions could theoretically be used to prop open wormholes or power Alcubierre drives without requiring the exotic matter that has plagued earlier proposals. The energy requirements would still be enormous, but they would at least be finite rather than infinite. Some researchers have proposed creating arrays of microscopic plates or specially designed metamaterials that could amplify Casimir effects to macroscopic scales. By carefully controlling the geometry and spacing of these structures, it might be possible to create stable regions of altered spacetime that could serve as launching points for faster-than-light journeys. The spacecraft wouldn't need to carry exotic fuel or massive energy sources. Instead, it would surf on the quantum fluctuations of space itself, using the universe's own quantum infrastructure as a highway to the stars. But perhaps even more intriguing is the possibility that life itself might already be exploiting similar quantum effects for purposes we don't yet understand. Consider the phenomenon of bird migration, where creatures no larger than your hand navigate across thousands of miles of open ocean to return to specific breeding grounds they've never seen before. Recent research has revealed that many migrating animals possess magnetic sensors that operate through quantum entanglement, allowing them to detect Earth's magnetic field with extraordinary precision. These quantum compasses work by creating pairs of entangled particles in specialized cells within the animal's eyes or beaks. Changes in the magnetic field alter the quantum states of these particles, providing a direct quantum interface between the biological system and the planet's magnetic environment. But here's where it gets truly fascinating. Some researchers have proposed that these same quantum sensing mechanisms might be capable of detecting other fields and forces that we haven't yet learned to measure. What if migrating animals aren't just sensing Earth's magnetic field, but navigating through higher dimensional space using quantum senses we can barely imagine? What if their seemingly impossible journeys across featureless oceans are actually shortcuts through folded spacetime? Invisible pathways that become accessible through quantum awareness? The mathematics of higher dimensional navigation suggest that what appears to us as epic migrations might actually be relatively short hops through the hidden geometry of reality. This biological perspective on faster-than-light phenomena opens up entirely new avenues for research. Instead of trying to build exotic spacecraft from scratch, perhaps we should be studying how living systems already achieve seemingly impossible feats of navigation and coordination. Flocks of birds wheeling through the sky in perfect synchronization. Schools of fish moving as if controlled by a single mind. Swarms of insects coordinating complex behaviors across vast distances might all be examples of faster-than-light communication operating through quantum channels we don't yet understand. Recent studies of quantum effects in biological systems have revealed that life operates much closer to the quantum realm than anyone previously suspected. Photosynthesis uses quantum coherence to achieve energy transfer efficiencies that approach theoretical perfection. Some researchers have proposed that consciousness itself emerges from quantum processes in the brain, creating a biological quantum computer that processes information in ways that transcend classical logic. If consciousness is indeed a quantum phenomenon, then perhaps the key to faster-than-light travel lies not in manipulating external spacetime, but in developing our own quantum awareness. Every moment of deep meditation, every flash of intuition, every experience of connection that transcends physical distance might be a glimpse of consciousness operating in quantum superposition, accessing information and experiences from across the cosmos instantaneously. This consciousness-based approach to faster-than-light phenomena suggests that the universe might be far more alive and interconnected than our current scientific models suggest. Perhaps what we think of as vast empty space is actually a rich medium of consciousness, filled with intelligence and awareness that we simply haven't learned to perceive. In such a universe, faster-than-light travel wouldn't require exotic technology, but rather the development of conscious abilities that we already possess in latent form. The implications extend beyond individual consciousness to collective awareness as well. If minds can connect across cosmic distances through quantum entanglement, then perhaps entire civilizations could evolve into distributed intelligences that span multiple star systems. Instead of individual beings traveling from world to world, advanced species might exist as interconnected networks of consciousness, sharing thoughts and experiences instantaneously, regardless of physical separation. This collective approach to faster-than-light phenomena would explain some of the puzzling aspects of reported UFO encounters and other anomalous experiences. Perhaps what witnesses interpret as physical craft visiting from distant worlds are actually manifestations of consciousness itself, projections of awareness from civilizations that have learned to transcend the limitations of matter and energy. The strange behavior often reported in such encounters, the apparent ability to appear and disappear instantaneously, to change shape and size, to seem both physical and ethereal, might all be natural properties of consciousness operating at quantum scales. Recent developments in quantum field theory have begun to provide mathematical frameworks for understanding how consciousness might operate across cosmic distances. The concept of quantum fields suggests that what we experience as separate particles and objects are really excitations in underlying fields that extend throughout all of space. Just as electromagnetic fields can carry information across vast distances at the speed of light, consciousness fields might carry awareness and intention across even greater distances at speeds that transcend our current understanding. Some physicists have proposed that consciousness itself might be a fundamental field of nature, similar to electromagnetic fields, but operating through mechanisms we don't yet comprehend. This consciousness field would permeate all of space, connecting every conscious being in a vast network of awareness that operates faster than light. Individual minds would be like radio receivers tuned to specific frequencies in this cosmic consciousness field, able to access information and experiences from across the universe through pure intention and focused awareness. The mathematical structure of quantum field theory suggests that such consciousness fields could indeed exist without violating any known laws of physics. The equations that describe electromagnetic fields and gravitational fields can be modified to describe fields that carry information about conscious states and intentions. These consciousness fields would interact with matter and energy in subtle ways, influencing the behavior of quantum systems through mechanisms that might eventually become measurable and controllable. If consciousness fields do exist, then faster-than-light travel might not require any external technology at all. Instead, it might require learning to consciously navigate through these fields, projecting awareness to distant locations, and potentially even manifesting physical presence through focused intention. This wouldn't be supernatural in any sense, but rather a natural extension of abilities that consciousness already possesses at quantum scales. The development of such abilities would represent a fundamental evolution in human consciousness, a transition from purely physical existence to a hybrid state where mind and matter interact in ways that transcend our current understanding. Perhaps this evolution is already beginning, expressed through the growing interest in meditation, consciousness research, and quantum physics that characterizes our current era. As you drift through these possibilities tonight, consider the fascinating fact that your own consciousness might already be operating faster than light in ways you don't consciously recognize. Every dream that carries you to distant places, every moment of inspiration that seems to come from beyond your individual mind, every feeling of connection with loved ones across vast distances might be evidence of consciousness naturally transcending the speed of light barrier. The universe, it seems, might be far more conscious and interconnected than we ever imagined, filled with intelligence and awareness that operates through quantum channels we're only beginning to understand. Our own journey toward faster-than-light capabilities might simply be part of a natural progression toward recognizing and developing conscious abilities that we've always possessed but never learned to use deliberately. Perhaps the greatest discovery awaiting us isn't a new form of technology, but a new understanding of what we are and what we're capable of becoming. The stars might not be distant destinations to be reached through exotic spacecraft, but aspects of our own expanded consciousness waiting to be explored through the unlimited potential of awareness itself. Tonight, as you rest and let your mind wander through these infinite possibilities, remember that the journey to understand faster-than-light travel is really a journey to understand the deepest mysteries of consciousness and reality. Every question we ask about transcending physical limitations is really a question about the nature of existence itself, and every answer we discover brings us closer to recognizing our own unlimited potential for exploration and discovery. The cosmos awaits, not as a foreign realm to be conquered, but as an expression of consciousness itself, accessible through the simple expansion of awareness beyond the boundaries we've assumed were absolute. In seeking to travel faster than light, we might discover that we were never separate from the destinations we hope to reach, but always connected to everything through the invisible threads of consciousness that weave the universe together in one magnificent, instantaneous whole. And perhaps that's the most beautiful aspect of this quest. Whether or not we ever build functional warp drives or step through traversable wormholes, the very act of seriously contemplating faster-than-light travel expands our understanding of what's possible. It pushes us to question our most basic assumptions about space, time, consciousness, and reality itself. It invites us to consider that the universe might be far stranger, more wonderful, and more alive than we ever dared to imagine. In the end, the search for faster-than-light travel might not be about getting somewhere else at all. It might be about discovering that everywhere we could ever want to go already exists within the infinite landscape of consciousness itself, accessible not through the manipulation of matter and energy, but through the gentle expansion of awareness into its true, unlimited nature. The speed of light may seem like an absolute barrier from our current perspective, but from the deeper perspective of consciousness, it might simply be one note in a cosmic symphony of possibilities that we're only beginning to hear. And as you drift off to sleep tonight, carried along by these gentle waves of wonder and possibility, remember that you're already travelling faster than light through the boundless realm of dreams and imagination, exploring worlds that exist beyond the reach of any spacecraft, guided by the unlimited potential of consciousness itself. The search for faster-than-light travel has led us down some remarkable pathways, but perhaps none more intriguing than the recent discoveries about the nature of information itself. In our digital age, we've grown accustomed to thinking about information as something abstract, patterns of ones and zeros flowing through fibre optic cables or radio waves, carrying data across vast distances. But quantum mechanics suggests that information might be far more fundamental than we ever imagined. At the deepest level, some physicists now propose that reality itself is made of information. Not matter and energy arranged in complex patterns, but pure information organized in ways that create the illusion of physical substance. If this is true, then the distinction between traveling through space and transmitting information across space might be meaningless. You might already be traveling at the speed of thought, in the sense that the quantum information that defines you is constantly being updated and propagated through the information fields that permeate all of reality. This information-theoretic view of the universe has profound implications for faster-than-light travel. If everything is ultimately information, then perhaps the key to superluminal travel lies not in moving matter through space, but in learning to manipulate the information structures that underlie physical reality. Imagine being able to edit the cosmic code that defines your location, changing your coordinates in the universe's database rather than physically journeying from one place to another. Recent work in quantum error correction has revealed that the universe itself might operate like a vast quantum computer, constantly processing information and correcting errors to maintain the stability of physical laws. Some researchers have proposed that what we experience as the passage of time might actually be the universe running its quantum software, updating the information patterns that define matter, energy, and space itself with each tick of the cosmic clock. If the universe is indeed a quantum computer, then perhaps sufficiently advanced beings could learn to hack this cosmic operating system, rewriting the code that defines their location and properties. Instead of travelling through space, they might travel through the information space that underlies physical reality, taking shortcuts through the computational architecture that runs the universe. This computational approach to faster-than-light travel might explain some of the strange phenomena reported in quantum mechanics. When particles become entangled, they seem to share information instantaneously, regardless of distance. Perhaps this isn't mysterious action at a distance, but rather evidence that entangled particles are really subroutines in the universe's quantum software, sharing the same memory address in cosmic storage. The mathematics of quantum information processing suggests that such information-based travel could indeed be possible without violating any fundamental laws of physics. Information can be compressed, encrypted, transmitted, and reconstructed using purely mathematical operations that don't require physical movement. If consciousness is an information pattern rather than a physical object, then perhaps it could be transmitted across cosmic distances using quantum communication protocols that operate faster than light. But the implications go even deeper when we consider the role of observation in quantum mechanics. The act of measurement doesn't just reveal information about quantum systems. It actually determines which of many possible realities becomes manifest. Every quantum measurement is an act of creation, collapsing infinite possibilities into a single, definite outcome through the intervention of consciousness. Perhaps faster-than-light travel doesn't require moving through space at all, but rather learning to observe distant locations into existence. If consciousness can collapse quantum wave functions to determine reality, then perhaps sufficiently focused awareness could observe itself into being at distant locations, creating a presence there through pure intention and quantum observation. This observer-based approach to faster-than-light phenomena would explain why consciousness seems to play such a central role in quantum mechanics. Perhaps the universe is structured as an interactive system, responding to conscious observation by manifesting the realities that consciousness chooses to explore. In such a universe, travel wouldn't be about overcoming physical barriers, but about learning to navigate the quantum landscape of possibilities with conscious intention. Recent experiments in quantum mechanics have begun to explore these possibilities in laboratory settings. Researchers have demonstrated that the act of observation can indeed influence the behavior of quantum systems in ways that seem to transcend normal causality. Quantum delayed choice experiments suggest that decisions made in the present can influence events that happened in the past, implying that consciousness operates outside the normal flow of time. If consciousness can influence past events through quantum observation, then perhaps it can also influence distant events, creating a form of faster-than-light interaction that operates through the timeless realm of quantum possibility. This wouldn't violate relativity because no information would be transmitted through space. Instead, consciousness would be directly interfacing with the quantum substrate that underlies all of space and time. The technological implications are staggering. Instead of building exotic spacecraft that manipulate spacetime, we might develop consciousness amplification technologies that enhance our natural quantum observation abilities. Imagine meditation chambers that use quantum field manipulation to amplify conscious intention, allowing trained operators to observe themselves into being at distant locations. Such technologies wouldn't require exotic matter or impossible energy sources. They would operate by enhancing abilities that consciousness already possesses at the quantum level, using the universe's own information processing capabilities as a transportation network. The spacecraft of the future might not be mechanical vehicles at all, but rather consciousness interfaces that allow minds to navigate through the quantum information space that underlies physical reality. But perhaps even more intriguingly, some researchers have proposed that such technologies might already exist in biological form. The human brain, after all, is a quantum information processor of extraordinary sophistication, containing billions of neurons that coordinate their activity through mechanisms we don't fully understand. Recent discoveries about quantum effects in biological systems suggest that the brain might already be operating as a quantum computer, processing information in ways that transcend classical physics. If the brain naturally operates at quantum scales, then perhaps the key to faster-than-light travel lies not in building new technologies, but in learning to consciously access abilities that we already possess. Every moment of deep concentration, every flash of intuition, every experience of connection that transcends physical distance might be evidence of the brain naturally interfacing with quantum information fields that extend across cosmic distances. This biological approach to faster-than-light phenomena suggests that evolution itself might be guiding us toward developing superluminal capabilities. Perhaps the increasing complexity of consciousness that characterizes human evolution is really a progression toward quantum awareness, the natural development of abilities that will eventually allow us to transcend physical limitations entirely. The implications for human development are profound. Instead of viewing ourselves as biological machines trapped in physical bodies, we might begin to understand ourselves as quantum information patterns that happen to be temporarily organized in biological form. This perspective suggests that consciousness is far more fundamental than matter, and that learning to operate consciously at quantum scales could unlock abilities that seem magical from our current perspective. Some researchers have proposed that advanced meditation practices might already be training the brain to operate at quantum scales in ways that could eventually lead to faster-than-light capabilities. When meditators report experiences of expanded awareness, feelings of unity with distant objects, or perceptions that transcend normal sensory boundaries, they might be describing the natural operation of consciousness at quantum scales. If this is true, then the path to faster-than-light travel might not require massive technological development, but rather the cultivation of consciousness itself. Perhaps the universe is already offering us countless opportunities to transcend physical limitations, but we can only perceive and utilize these opportunities when our awareness expands to match their subtlety and sophistication. This consciousness-based approach to faster-than-light travel would also solve many of the paradoxes that plague other proposals. If consciousness naturally operates outside the normal flow of space and time, then apparent violations of causality wouldn't be violations at all, but simply evidence of consciousness accessing reality from a perspective that transcends our usual three-dimensional, linear time viewpoint. Perhaps the greatest barrier to faster-than-light travel isn't physics or technology, but our own assumptions about what we are and what we're capable of becoming. The journey to the stars might really be a journey inward, toward a fuller understanding of consciousness and its unlimited potential for transcending apparent limitations. Recent developments in neuroscience have begun to reveal just how plastic and adaptable human consciousness actually is. The brain's ability to rewire itself, to form new neural pathways, to adapt to changing circumstances is far greater than anyone previously imagined. Some researchers have proposed that consciousness itself might be infinitely adaptable, capable of expanding into new dimensions of awareness that we can barely conceive of today. If consciousness is indeed infinitely plastic, then perhaps there are no fundamental limits to what aware beings might eventually become capable of achieving. The speed of light might seem like an absolute barrier from our current perspective, but from the perspective of expanded consciousness, it might simply be one constraint among many that can be transcended through the natural evolution of awareness itself. This evolutionary perspective suggests that faster-than-light travel might not be something we develop through technology, but something we grow into as our understanding of consciousness deepens. Perhaps the universe is already filled with advanced beings who have transcended physical limitations through the expansion of awareness, and our own journey towards superluminal capabilities is simply part of a natural progression toward joining this cosmic community of consciousness. The search for faster-than-light travel thus becomes a search for the deepest truths about what we are and what we might become. Every meditation that quiets the ordinary mind, every moment of expanded awareness that transcends normal boundaries, every experience of connection that bridges apparent separation might be a step toward developing the consciousness necessary for quantum navigation through space and time. As we float through these possibilities, we begin to see that the question isn't really whether faster-than-light travel is possible, but whether we're ready to expand our understanding of possibility itself. The universe might already be offering us countless pathways to transcend physical limitations, but we can only perceive and utilize those pathways when our consciousness evolves to match their elegance and sophistication. Perhaps the most beautiful aspect of this quest is that it invites us to discover our own unlimited potential. Whether or not we ever build functional warp drives or step through traversable wormholes, the very act of seriously contemplating faster-than-light travel expands our sense of what might be possible. It pushes us to question our most basic assumptions about reality and opens our minds to possibilities that seemed impossible just moments before. Tonight, as you rest and let these ideas settle into your awareness, consider the fascinating possibility that you might already possess everything needed for faster-than-light travel. Not in the form of exotic technology or manipulated spacetime, but in the form of consciousness itself, with its natural ability to transcend the boundaries of space and time through the simple act of expanded awareness. The stars are calling, not just to our rockets and machines, but to our minds and spirits. And perhaps the day will come when we answer that call not by conquering the universe through force, but by discovering that we were always part of a cosmic consciousness that naturally operates faster than light, limited only by our belief in limitations themselves. The universe awaits, vast and mysterious and closer than we ever imagined, accessible not through the manipulation of matter and energy, but through the expansion of consciousness into its true, unlimited nature. And in that expansion, we might discover that faster-than-light travel was never about getting somewhere else, but about recognizing that we were already everywhere, always connected to all things through the invisible threads of awareness that bind the cosmos together in one magnificent, instantaneous whole. As these gentle waves of possibility wash over your mind like starlight on still water, remember that the greatest discoveries often come not through struggling against apparent limitations, but through relaxing into a deeper understanding of what reality actually is. The speed of light might seem like an absolute barrier from one perspective, but from another perspective entirely, it might simply be one note in a cosmic symphony of possibilities that we're only beginning to hear. The journey toward understanding faster-than-light travel has already begun to transform our understanding of consciousness, reality, and our place in the cosmic order. Whether that journey ultimately leads to exotic spacecraft or expanded awareness, to technological breakthroughs or evolutionary leaps, it has already enriched our sense of wonder and possibility immeasurably, and perhaps that's enough for tonight. As you drift off to sleep, carried along by these gentle currents of curiosity and imagination, know that you're participating in one of humanity's greatest adventures, the quest to understand the deepest mysteries of existence itself. In seeking to travel faster than light, we're not just trying to reach distant worlds, we're trying to discover what it truly means to be conscious beings in an infinite universe full of wonders beyond imagination. The cosmos, it seems, might be whispering secrets we're only just beginning to hear. As we drift toward the end of our gentle journey through the realm of faster-than-light possibilities, perhaps it's worth considering what all of this means for us here, tonight, in this quiet moment between waking and sleep. The search for ways to transcend the speed of light has led us through some truly extraordinary territory. We've floated past Alcubierre drives that surf on waves of twisted spacetime, wandered through hypothetical wormholes that could connect distant galaxies like cosmic shortcuts, and contemplated particles called tachyons that might naturally travel faster than light. We've explored how quantum entanglement creates mysterious connections that seem to operate instantaneously across any distance, and how consciousness itself might hold the key to navigation through dimensions we can barely imagine. But perhaps the most profound discovery isn't any particular technology or theory. Perhaps it's the gradual realization that the universe is far stranger, more interconnected, and more alive than we ever dared to imagine. Every proposal for faster-than-light travel, from the most rigorous mathematical formulations to the most speculative consciousness-based approaches, points toward the same fundamental truth. The boundaries we assume are absolute might be far more permeable than they appear. Consider how much our understanding has already evolved. Just over a century ago, human flight seemed impossible. The idea of communicating instantly with someone on the other side of the world would have been dismissed as fantasy. The notion that we could split atoms, decode the structure of DNA, or send robotic explorers to other planets would have sounded like the ravings of dreamers lost in impossible visions. Yet here we are, living in a world where all of these impossibilities have become everyday realities. The smartphone in your pocket contains technology that would have seemed magical to someone from even a few decades ago. You can video chat with someone on another continent, access the sum total of human knowledge with a few taps, and navigate anywhere on Earth using signals from satellites orbiting hundreds of miles above. If the impossible has become possible so many times before, who's to say that faster-than-light travel will forever remain beyond our reach? Perhaps we're simply in the earliest stages of understanding phenomena that will one day seem as natural and obvious as electricity or radio waves do to us now. The research continues in laboratories around the world where scientists probe the quantum vacuum for signs of manipulable structure. In theoretical physics departments where brilliant minds wrestle with equations that describe the deepest layers of reality. In consciousness, research centers where the relationship between mind and matter is explored with increasing sophistication. Each small discovery adds another piece to a puzzle whose final picture we can only dimly imagine. Recent breakthroughs in quantum computing have demonstrated that reality operates according to principles that would have seemed like pure fantasy just a few years ago. Quantum computers can process information in ways that transcend classical logic, solving certain types of problems that would take conventional computers longer than the age of the universe to complete. If consciousness itself operates as a quantum computer, as some researchers now suspect, then perhaps it already possesses capabilities that we're only beginning to recognize and develop. The universe, it turns out, is not the cold, mechanical clockwork that scientists once imagined. It's a living, breathing, evolving system of extraordinary complexity and beauty, where consciousness and matter dance together in ways that blur the boundaries between observer and observed, between mind and reality, between what is and what might be. And perhaps that's the most comforting thought of all. We're not isolated biological machines struggling against an indifferent cosmos. We're conscious participants in a universe that seems designed to support awareness, creativity, and the endless exploration of possibility. Every question we ask, every boundary we push against, every dream we dare to dream contributes to the ongoing evolution of cosmic consciousness itself. The stars above you tonight might seem distant and unreachable, cold points of light separated by impossible gulfs of space and time. But perhaps they're not as far away as they appear. Perhaps the universe is more intimate, more connected, more alive than our current understanding suggests. Perhaps the consciousness reading these words right now is already connected to every star, every planet, every form of awareness that exists anywhere in the cosmos, through quantum threads, too subtle for our instruments to detect but real enough to carry information, intention, and love across any distance instantaneously. Whether faster-than-light travel ultimately comes through exotic technology or expanded consciousness, through manipulated spacetime or quantum navigation, through collective intelligence or individual transcendence, the journey toward that goal has already transformed us. It has expanded our sense of what's possible, deepened our appreciation for the mystery and wonder of existence, and reminded us that we live in a universe where the impossible has a curious habit of becoming inevitable. So as you settle into sleep tonight, carried along by these gentle currents of possibility and wonder, remember that you're already traveling faster than light through the boundless realm of dreams and imagination. In that space beyond space, that time outside of time, you can visit any world, explore any possibility, connect with any consciousness that has ever existed or ever could exist. The speed of light may be the ultimate limit for matter and energy, but consciousness operates by different rules entirely. In the landscape of awareness, distance is measured not in miles or light years, but in degrees of understanding, connection, and love. And in that infinite realm, you're already home wherever you choose to be. The universe is vast and full of wonders beyond imagination, but it's also intimately close, woven into the very fabric of your being through quantum threads that connect all things in one magnificent, timeless whole. Whether we ever build spacecraft that travel faster than light or learn to project consciousness across cosmic distances, we're already part of something far grander than any individual journey could ever encompass. And perhaps that's the deepest truth about faster than light travel. It's not really about getting somewhere else. It's about discovering that everywhere we could ever want to go already exists within the infinite landscape of consciousness itself, accessible through the gentle expansion of awareness beyond the boundaries we once thought were absolute. The cosmos awaits, not as a foreign realm to be conquered, but as an expression of the same consciousness that reads these words right now. The journey to the stars begins not with exotic spacecraft, but with the recognition that you are never separate from the destinations you hope to reach, connected always to everything through the invisible threads of awareness that weave reality together like starlight dancing on still water. Sleep well, fellow traveller. Dream deeply of impossible worlds and faster-than-light journeys, and know that in the quiet realm of rest and wonder, you're already exploring territories that no spacecraft could ever reach, guided by the unlimited potential of consciousness itself as it flows like gentle starlight through the infinite darkness, carrying you home to places you never left and worlds you've always known. Sweet dreams, dear listener, and may your rest be filled with gentle journeys through realms where light itself seems slow, where consciousness moves at the speed of wonder, and where every star whispers secrets of connection across the infinite tapestry of space and time. And so we arrive at the quiet end of our cosmic voyage, having drifted together through the extraordinary landscape of faster-than-light possibilities. We've wandered past the mathematics of the impossible, floated through theories that bend space and time like warm honey, and contemplated the profound possibility that consciousness itself might be the ultimate faster-than-light technology, operating through quantum channels we're only beginning to understand. What a remarkable journey it's been, from the rigid barriers of Einstein's speed limit to the fluid possibilities of quantum navigation, from exotic spacecraft riding waves of twisted spacetime to the simple recognition that awareness itself might already transcend every boundary we once thought absolute. Each idea we've explored has been like a gentle star in the constellation of human curiosity, illuminating not just what might be possible, but what it means to be conscious beings in a universe far stranger and more wonderful than we ever dared imagine. If you found yourself still awake at the end of our gentle exploration, well, at least you've journeyed through some of the most profound questions that minds can contemplate. And if these ideas have carried you softly toward the realm of dreams, then perhaps you'll find yourself exploring impossible worlds where the speed of light is just a gentle suggestion, and consciousness flows like starlight through dimensions we can barely conceive. Before we part ways on this quiet night, I'd be ever so grateful if you gave this video a gentle like, and perhaps considered subscribing to join me for more peaceful journeys through the wonders of science and possibility. It helps other curious souls find their way to these calm explorations, and it means the world to this sleepy corner of the universe. Until we meet again in the vast realm of wonder and possibility, may your dreams be filled with faster-than-light journeys through cosmic meadows of starlight, and may you always remember that the greatest discoveries await not in distant galaxies, but in the infinite landscape of consciousness itself. The universe is calling, gentle and patient as always, whispering secrets of connection that transcend every apparent limitation. Rest well, fellow traveller of the cosmic sea. The stars are singing lullabies tonight, and somewhere in the quantum foam of space and time, faster-than-light dreams are already coming true.